Hello and thank you for watching the fifth lesson of chapter 1, which is 1.5 Secure Remote Access. In this lesson, you will learn the difference between the Telnet unsecure protocol and SSH secure protocol. I will do a demonstration for you how to connect to the Cisco device using Telnet protocol and SSH protocol, and you see the difference. Telnet is an older protocol that does use a reliable delivery of the packets, which use port number 23, but all the communication between the source and destination is in clear text. Username, password, and data, everything will be in clear text. So if there's an attacker or man in the middle, we'll be able to see all the communication. Whatever we're doing, we'll be able to read. However, SSH, it uses port 22, TCP as well, but the communication is all encrypted. So if it's man-in-the-middle attack, if it gets our packets, won't be able to make a sense of what we are communicating. Okay, so for this lesson, I'm gonna use GNS and VMware to show you. So I've got already a GNS open here, and I'm just gonna bring a router C7200, and I'm going to bring a cloud, which is going to be the connection for my VMware machine. So I already have a connection to VMware, which is going to be this PCA. And PCA, if you look, the PCA, the network adapter is VMnet 15. So I'm going to use that, okay? Okay, so let me go to the GNS again. And now this cloud, I can right click it and say configure, and I will use port. I need VMnet 15, but it doesn't show here, so I need to use this show special Ethernet interfaces. So click that, and I'll select a VMnet 15, which is in the other screen, but here, VMnet 15, and click add, and click OK. Then I can right click and just change the symbol, so I just want to see, for example, a PC rather than cloud. So classic and PC. Okay. And this is going to be PCA. And I'm going to connect this PCA VMnet 15 with my router fast Ethernet 00. I have that connection. So then on the router, I'm just going to right click and select start, and then right click again and go to the console once it starts. Okay, I have access to the router here. So I'm just going to do a basic configuration on this router so PC and the router can communicate with each other. So if I go to the VMware and then PCA, I resume that PC. And we're just going to look at what IP address does PCA use. Yeah. Okay. Go back to the router. I think the router is already done. Okay. So I'm going to go and do a small startup configuration here. For example, the name is already there. Yeah. So router 1, enable secret class. So this you should know from the CCNA1 really. You should know what I'm doing. Enable service password encryption, and then no IP domain lookup, and then I'll do for example banner and message of the day banner. So authorized users only, and then I'll do a line console 0, password Cisco, login, exec timeout 00, login sync. All these commands, you should know them from CCNA1. If you don't remember them, you need to go back and have a look at them. Password here, Cisco, login, and save these, yeah? So I'll have to do copy, running config to startup config. Just the basic startup configuration. Okay, done. So if I go to PCA, and in here, I just want to close all the commands I have. Continue without saving. Close this, close everything. Then I'll go to the command prompt and I'll just do ipconfig. Right, the address of this PC is 10.1.1.10 and the gateway is 10.1.1.1. So that's what we're going to give to the router, that IP address. So if I go to the router, config t, interface FA00, description, I'll do router 1 to PCA, and IP address 10.1.1.1, and no shutdown, right? So, and then I'll do show IP interface brief, and you can see the fast Ethernet interface has got an IP address. Layer 1, which is the status, is up. Layer 2 says the protocol is up. Fast Ethernet 01, the second interface, for example, doesn't have an IP address. It's unassigned, and it's administratively down, which means the administrator has shut down the interface. To bring back up the interface, we have to do no shutdown. So just to see that I have a connection with PC, I'll do ping 10.1.1.10, and it seems like everything is working. I can ping the PC, and if I go to PC, do ping 10.1.1.1. Well, I'll do a continuous ping just to make sure that actually there is a connection. So I'll go here and I'll go to that interface. So config T interface fast Ethernet 00, shut down. This is to switch the interface down, off, and the pings should actually fail there. As you can see, they are failing. Okay, so when I do no shutdown, the pings, they should start coming once the interface changes state to up, right? So it's gone up, the interface is changed up, and there we can see we have pings. Great. There is a communication between the PC and the router. So now I'm going to connect to the router using Telnet. Yeah. So first I'm going to start the Wireshark and capture interfaces. Only one interface, I'll start there. And then I'm going to run PuTTY, and I'm going to access the router using Telnet. You can see 10.1.1.1. Now when I say Telnet, you can see port 23. And if I say SSH, that's SSH port 22. That's encrypted. That's clear text 23. So click that open, and I have access. So Cisco enable class, right? So I'll go connection. Everything is being copied in the Wireshark, so we can see it later. So now I need to do some commands. So show IP interface brief, for example. Show run, for example, running config. Let's see what's in running config. And maybe show IP route. There we go. Just generated some traffic. So now when I go to the Wireshark, and it has captured quite a few bit of data here, Telnet data, and I can stop this capture. So capture, stop. And if I just right click on any of these Telnet data, I can right click it and say follow TCP stream. And you can see everything is in clear text. Authorized users only. Everything in red is the initiators. Everything in the blue is the responders traffic. So this is what I typed, Cisco. Then I typed enable. So every thing I typed, the responder is giving me what I'm typing. So enable, class, and you can see everything I did. Everything is in clear text. That is very dangerous. Very, very dangerous. And you can see everything. Then I did show IP route, and you can see that's in the clear text as well. Right. That is clear. That is Telnet. Right. So what we're going to do, the next thing is we're going to do actually enable SSH. But to enable SSH, for example, what we need to do, few things. That's why we don't start teaching you CCNA 1 right away with SSH, even though that we have covered this in CCNA 1. So SSH has some requirement. Number one, the host name has to be changed. So host name, change from the default. You need to change it to something else. Number two, you need to create a domain name. So IP domain. So domain has to be created. Number three, create the certificates, like certificates has to be created. Once we did all these three, then we create a local username local user database. So we can do that, create a database, a local database, local user database, and then we have to go to VTY lines, VTY, and say the login is going to be local. if I say login local, that means use a local database for logins. And we have to put a transport input, in say input SSH, which we allow in only SSH and not Telnet or nothing else. That's right. So this is what we actually have to configure. So first we verify that we can support SSH traffic. Then we configure the device with a host name. And this is to verify that as long as you have K9, it does support, for example, it does support cryptology, so it should be fine. Configure the host name, configure the IP domain name, um, generate RSA key pairs, configure user authentication like a local user authentication database, and then on the VTY lines, enable SSH version 2 and enable the local authentication from the local database. Okay, so if I go to the router, so I'm back at the router here, and if I type exit, and here I would have changed the name, so hostname R1, but that's already done, yeah. So then I'll do IP domain name cisco.local. You can choose whatever your domain is here. So that's your second step. It's great. And then we have to create, for example, certificates. Let's do that. We can create a cryptology if we can check first. So um, show IP SSH, and you can see that SSH is disabled at the moment, but that means that we can run SSH. We can enable it, and right. So we can do that even the show version as long as it's our operating system is K9. That will be able to run it anyway. Okay. So if I do configure terminal, and in there host name, then the domain name, then crypto key generate RSA, and it will tell us that 512, that's not enough, actually 1024. Okay, and we have generated, we did all these 4 steps on the top here. The next thing we're going to do is we're going to actually create a local username and password database. So username, say Astrid, secret, say class, and that's it. Then I need to go to line VTY 0 to 4, login, local. So now we are using the local database for logins. Instead of before, we just had login. But if you have a login, then you have to have a password here. If you have a login local, then you have to use we're saying to be using a local database for logins. Okay, and then we can say transport input. So enter there and transport input SSH. There we go. Now, if I go back to the PC and I try to log on through using Telnet, that's not going to allow me. So if I go to PuTTY and try Telnet, and that should say connection refused. There you go, connection refused. Okay, so let me start a packet tracer. So Wireshark, take another capture. So capture, start, continue without saving, and now I'm going to access through using SSH. So go to PuTTY, SSH default port 22, and the IP address of the router is 10.1.1.1. And you can see right away I'm getting a warning from the PC because it's saying this is not a trusted certificate. Are you sure that you want to go forward? Yes, we are. And now you can see login as. So now I can type Astrid there. And password, it was class. And you can see that now I'm inside the router. So enable. I think it's class, yes. Show IP interface brief. Just generating some traffic. Show run. So between the responder, initiator and responder, and show IP route, same as what we did before. But now when I go to Wireshark, you should see that some SSH traffic is already being copied, right? And what we can do is we can stop this capture, right click on the SSH, and follow TCP stream, and you can see now everything is encrypted. Now there's nothing here. There's actually we can understand as if you were like a man in the middle. There's no way you can understand any of this, yeah. Now SSH by default is going to run version, it's not going to run version 2, so we need to actually enable version 2. So type IP SSH version 2, right? And then show SSH, and you can see SSH has started by whatever user has started that SSH and what version we are running and so on. We can also say show IP SSH, for example, and you can see that SSH is enabled and be running version 2.0. So authentication timeout and retries, that's for the future. So if I create another user, for example, say user name and say admin secret, but before I put the secret, let me put privilege 15. That means as soon as administrator logs in, it will go straight to the privilege mode, so it doesn't have to type enable. And secret, let's say class. Right. Now, if I go to Wireshark again, and I'll start a new capture. So capture, start. Okay, clear this. And then I'll go and start a new, but this time I'm going to log in as admin. So SSH 10.1.1.1 and type admin, password class. And you can see I'm already on privilege mode. I didn't have to type enable. But if I log in as me, for example, Astrid, so 10.1.1.1, right? That's going to be my logins. So here I put Astrid and password class. You can see I'm in the user mode, but the administrator is in the privilege mode because we did the configuration privilege exec 15 for the administrator. So here me, I need to type enable and then class, and then I'm in the privilege mode. Okay, so all these SSH traffic, for example, is version 2 here now, right? And I can click on any of the SSH and select follow TCP stream, and you can see everything is encrypted. So for that, you should be using SSH rather than Telnet. Okay, excellent. I see. I hope you enjoying this stuff. This is so interesting stuff that you can actually see it on the Wireshark, what we're talking about. Some of the verification commands, for example, show interfaces. So if I go to the router and just going to run the commands here. So if I just do this and say end here, and we do show interface, say show interface, for example, fast Ethernet 00. That's going to show me what is that interface, what's in information about that interface. For example, let me just move this to here. We can see the MAC address that we are using, the MAC address that it's burned in, and we can see the description for this interface. We can also see the layer 1 is up and layer 2 is up, and we can see the IP address of this interface, the MTU they support, what duplex we are using, full duplex, and how many megabits per second we are using, so 100 megabits per second, as well as what other information, good information is the queuing strategy that we're using here, and do we have any errors. So for example, any collisions, nothing in there. So any input errors and output errors. Input errors, 0 CRCs, 0 overrun. Output errors, for example, we have here, no collisions, no late collision. We just started anyway. We just started this interface, so that's why there's nothing in here. There's no. Okay. The next command is show IP interface. So show IP interface FA00, for example. And here is the interface. Show interface is more about layer 2 stuff information. Show IP interface, however, is more geared towards layer 3 information. Again, layer 1 and layer 2 information, IP address, subnet mask, broadcast address for that, subnet mask is here, /24. The MTU, the ICMP, redirect are always send, unreachable are always send, the CEF that we are using, which is enabled, right? Other configuration, show startup, right? Or show running config. Now running configuration and startup configuration, they don't have to be the same. So for example, let's say I'll change the name here. So host name, say Astrid R1, right? That is my running configuration. The name of the router is R1. If I do show running config, you can see the name is whatever I just typed. So that's the name, R1. If I do show startup configuration, for example, that's going to be different. Show startup, that is different. It's R1, hostname R1. So you can see the startup doesn't have to be the same as running configuration. If you made changes, you need to save those changes to take effect. Yeah. Show flash, show version. So for example, if I do show flash, well, anyway, this is because it's a GNS, so it's not going to be great. Show version. Maybe it's better if we do this on the packet tracer, for example. But we can see in the show version, we can see what operating system we are running. For example, other stuff is the memory that we have. We can see what interfaces we have, how much flash we have, and the default configuration register here we have. Show history. Show history is like what commands, the 10 last commands that you added in the history. So these are my 10 last commands that I put. I can go through these commands if I press up arrow, and I'll go through the commands. You can change the size of the history. For example, if you don't want anything to be saved, you can say history 0. Or maybe you do want to, like for example, increase the history size. You can change it to something else, up to 255. Okay. Right. And then show MAC address table. Well, this is for the switches, not for the routers. We already have a router. We looked at the input errors. So input errors, for example, we can see the runt. If you remember, the runt is anything less than 64 bytes, while giant, anything above 1518 was a giant. So we can see the errors, the cycle redundancy check errors, frame check sequence, output errors, collisions, or late collisions here. Thank you for watching lesson 1.5, Secure Remote Access. This is of chapter 1, Basic Device Configuration. Please have a look at my other videos in YouTube channel, and don't forget to subscribe to stay up to date with what I'm doing. This has been Astrid Krasniqi. Bye bye.